Hey everyone, and a massive welcome to the channel. Seriously, thank you so much for clicking on this video and taking a bit of time out of your day to hang out here with me. Before we dive into what is, I promise you, one of the most strangely fascinating topics nature has to offer, I want to take a quick moment to just send some positive energy your way. Wherever you are in the world, whatever you're going through, I genuinely hope you're feeling okay, that you're surrounded by good people, and that you and your loved ones are happy, healthy, and safe. It's easy to forget to take care of ourselves sometimes, so consider this your little reminder to just breathe and be kind to yourself today. Alright, with that wonderful energy flowing, let's get into it. So, picture this. You're hiking through the beautiful, rugged bushland of Australia. The air is fresh, the birds are singing, and you're just soaking in all the incredible nature around you. You come across a fallen log, and there, on top of it, is something that makes you stop and blink, because your brain immediately tells you that what you're looking at shouldn't, and couldn't, possibly exist. Lying there, neat as you please, is a small pile of poop. But this isn't your ordinary, everyday animal dropping. This poop is perfectly, unmistakably cube-shaped. Not rounded, not pellet-shaped, not a messy pile. I'm talking about sharp edges, flat sides, little fibrous cubes, looking like they were just extruded from some kind of biological factory line. Your first thought might be that some joker has come along and placed a bunch of tiny brown dice on a log as a prank. But I'm here to tell you that this is 100% real. This is the handiwork of one of Australia's most adorable and stubborn little bulldozers, the Wombat. And for the longest time, the question of how and why a wombat produces cube-shaped poop was one of nature's most charming and perplexing mysteries. I know what you're thinking. How is that even possible? Our entire understanding of biology and physics tells us that what comes out of a soft, fleshy, tubular intestine should be, well, tubular, soft, squishy, rounded. Think about every other animal you know. It's a universal truth of the animal kingdom. Except, it seems, if you're a wombat. For them, the rules are different. This isn't just a quirky little oddity. It's a serious scientific head-scratcher that has puzzled biologists for decades. It seems to defy the basic principles of how materials behave. It would be like squeezing toothpaste out of a tube and having it come out as a stack of tiny bricks. It just doesn't make any sense. But nature, as it so often does, has found a way. A brilliant, efficient, and utterly bizarre way. And the journey to uncovering this secret is a fantastic story of scientific curiosity, high-tech engineering, and a whole lot of people thinking very deeply about animal poop. First, let's get to know the star of our show a little better. The wombat is a marsupial, which means it's a cousin to kangaroos and koalas, and like them, it carries its young in a pouch. But that's about where the similarities end. Wombats are built like tanks. They are stout, muscular, and incredibly powerful diggers. They have short but strong legs equipped with big claws perfect for shoveling dirt. They spend their nights tirelessly excavating enormous burrow systems that can be over 30 meters long and several meters deep. These burrows are masterpieces of engineering, providing a cool escape from the hot Australian sun and a safe haven from predators. An adult wombat can be about a meter long and weigh anywhere between 20 and 35 kilograms. They look a bit like a small, very muscular bear or a giant, grumpy guinea pig. And they have a personality to match their rugged appearance. They are often described as stubborn, solitary, and determined creatures. If a wombat decides it wants to go somewhere, it will literally bulldoze through anything in its path, including fences, small shrubs, and, legend has it, even the legs of an unsuspecting human who gets in the way. They are not to be trifled with. Now, all that digging and bulldozing requires a lot of energy. So, what does a wombat eat? They're strict herbivores, and their diet consists almost entirely of tough, fibrous, gritty grasses, sedges, and roots. This is not exactly premium, easy-to-digest cuisine. It's loaded with hard-to-break-down cellulose. To get any nutrition out of this material, a wombat's digestive system has to be exceptionally efficient and, frankly, pretty hardcore. Food can take up to 8 days to make its way through a wombat's long digestive tract, which is one of the longest relative to body size of any mammal. Their intestines can be up to 10 meters long. This extended journey allows gut bacteria to slowly and methodically break down the tough plant fibers, extracting every last bit of moisture and nutrient possible. This incredibly efficient process results in waste that is very, very dry and compacted by the time it reaches the end of the line. It's like sawdust that's been pressed together. This dryness is a key part of our cubic puzzle, but it's not the whole story. Plenty of animals have dry poop, but only one makes cubes. So, the big question, how do they do it? For years, the leading theory was a simple, mechanical one. People speculated that maybe the wombat had a uniquely square-shaped anal sphincter. The idea was that the muscles at the end of the digestive tract somehow pinch the waste into a cube shape on its way out. It's a simple and somewhat amusing idea, but if you stop and think about it from an engineering and biological perspective, it doesn't really hold up. Muscles contract in a circular pattern. They can't contract in a way that would create straight lines and sharp, 90-degree angles. A sphincter is a ring of muscle. When it contracts, it makes a smaller circle, not a square. Trying to form a cube with soft tissue alone would be like trying to make a cube by squeezing Play-Doh with a round cookie cutter. It just wouldn't work. So, scientists knew the answer had to be deeper inside, somewhere along that long, 10-meter journey the food takes. The real breakthrough in this mystery came from an unlikely collaboration. It wasn't just biologists who were fascinated by this. The problem of the cubic wombat poop also captured the imagination of mechanical engineers and physicists. They saw it not just as a biological curiosity, but as a fascinating problem in fluid and solid dynamics. How does a soft, biological material become a rigid, geometric solid? To solve it, researchers needed to look inside a living wombat, a task easier said than done. You can't just ask a wombat to hold still for an MRI scan while it's doing its business. The solution was as grim as it was ingenious. Scientists studied the digestive tracts of wombats that had, unfortunately, been hit by cars. By carefully dissecting these tracts and examining their properties, they could begin to piece together the process. What they discovered was that the secret isn't at the very end. It's not about the exit. The magic happens in the last sections of the wombat's intestine. The wombat's intestine is not a uniform tube. Its walls have varying thicknesses and stiffness. Some parts are more stretchy and elastic, while other parts are much more rigid and firm. This creates a unique environment where the already dry and fibrous fecal matter gets slowly squeezed and molded as it moves through. The key finding was that the last 8% or so of the intestine, near the end, is where the final shaping occurs. This part of the intestine isn't round. Its lining has a series of grooves and stiff, elastic ridges. Think of it like a long, flexible ice cube tray, but one that's constantly gently contracting. As the dehydrated and compacted waste matter is pushed through this final section by the rhythmic muscular contractions of the intestine, known as peristalsis, it passes through these zones of varying flexibility. The softer, more elastic parts of the intestinal wall allow the material to expand a little, while the stiffer, grooved parts hold their shape and keep the corners sharp. It's a slow, gradual process of molding. Over a period of several days, the constant, gentle pressure from the intestinal walls sculpts the material into its now famous cubic form. The extreme dryness of the poop is critical here. If it were wet and soft, it would just squish into a blob. But because it's so dry and fibrous, it holds its shape like compacted sawdust or wet sand that can hold the form of a sandcastle. By the time it reaches the end, the shape is set. The anal sphincter doesn't need to be square, it just has to open and let the preformed cubes pop out. So, it's not a process of extrusion, like squeezing Play-Doh. It's a process of slow, meticulous molding inside a very specially adapted organ. Alright, so we have a good idea of the how. But that immediately leads to the next, equally important question. Why? Why on earth would a wombat evolve such a complex and unique biological mechanism just to make square poop? In nature, form almost always follows function. An adaptation this specific must provide a significant survival advantage. It turns out, those little cubes are incredibly useful for a solitary, territorial animal like the wombat. Wombats are creatures of habit. They have well-defined home ranges and a network of burrows within that territory. They are also mostly nocturnal and have relatively poor eyesight. So, how do they communicate with each other? How does a wombat leave a message for a neighbor saying, "I live here," or "This area is taken," or even "I'm looking for a mate"? They use their poop. This is a common behavior in the animal kingdom known as scent marking. The poop contains chemical signals, hormones, and other information about the wombat that left it. But here's the problem with round pellets. They roll. If a wombat placed its droppings on a rock, a log, or a raised clump of earth to better broadcast the scent, a round pellet would be likely to just roll right off and be lost in the undergrowth. A cube, with its flat sides and sharp edges, does not roll. It stays exactly where it is placed. It's a stable, sturdy messaging platform. Wombats are known to carefully arrange their cubed droppings in prominent places around their territory, creating little piles that act as signposts. They might even create larger piles the deeper you go into their core territory, almost like a warning sign that says, "You are getting very close to my home. Proceed with caution." The cube shape ensures that these signposts remain in place, faithfully broadcasting their chemical messages to any other wombat that passes by. It's a brilliant, low-energy communication system. They don't have to fight to assert territory constantly. They can just leave their cubic calling cards around the borders. It's efficient, it's effective, and it's a testament to how evolution can find the most ingenious solutions to everyday problems. The wombat, through its unique digestive system, has essentially invented biological post-it notes. The discovery of how the wombat intestine works has implications far beyond just solving a fun nature mystery. Scientists and engineers are incredibly interested in the process because it represents a new way of manufacturing. We usually make cubes by cutting, casting, or extruding materials under high pressure. The wombat does it gently at low pressure inside a soft, flexible tube using nothing but variations in tissue elasticity. This could inspire new ways to manufacture and shape soft materials, especially in fields like medicine and clinical research. Understanding this natural process could lead to better techniques for creating soft, squishy materials into specific shapes without the need for expensive and complex molds or cutting tools. It's a field of study known as biomimicry, where we look to nature for brilliant engineering solutions. So, the humble wombat, through its bizarre bathroom habits, might one day contribute to advancements in technology that help people. It's a wonderful thought. So, the next time you see a picture of a wombat with its cute, stumpy legs and grumpy little face, I hope you'll see it in a new light. This isn't just a cute Australian animal. It's a powerful digger, a stubborn survivor, and a biological marvel. It is a living testament to the endless creativity of evolution, proving that even the most mundane bodily functions can be refined into something extraordinary. In the harsh Australian outback, where every drop of water and every bit of energy counts, the wombat has perfected the art of waste management and communication, all wrapped up in one neat, cubic package. It's a reminder that nature always has more secrets to reveal, more wonders to show us, often in the places we'd least expect. Thanks for joining me on this wonderfully weird journey. Take care.